I did specifically say candy. Well, but chocolate is a type of candy. Okay, so Malak wants broccoli. Sounds good. That's kind of candy. All right. Today we're going to do very much review, very much something you've done before. The preliminary stuff to this unit, conversions, looking at units, figuring out what units we use for certain things. So, first of all, talking about length. Living in Canada is a little bit confusing. What system do we use for measurements in Canada? We use the metric system. But do we always use the metric system? No. Carter, how tall are you? So 5 meters at 9 centimeters? Right, 5 foot 9 inches. He used imperial. He used imperial. Right, so in terms of height, it's very rare for someone to talk about themselves in metric. We do more often say feet and inches. That would be more common. Even though technically we use metric, if I ask any of your height, you're more likely to tell me it in imperial. Maybe you just recently got your driver's license and it says you're 175 centimeters, that's what harder is. But for most of us, we probably instead are remembering feet and inches, and I'm thinking, oh, well, I'm 6'7" because I'm almost as tall as Kevin Durant, who's 6'9". Maybe not. Maybe I'm 5'9". So in general, that's what. Okay, how about this? Cole, how far is it to Calgary? Oh, interesting. Hey, listen to this. I asked Cole how far it was to Calgary. He answered in a unit of time. So I asked him how far is it to Calgary. People often say, oh, to Calgary's about 3 hours. But wait, that's not a distance of. That's not even a distance. That's a bit of time. What he's saying is, driving at highway speeds, it takes about 3 hours to get to Calgary. Very nice. It's something like 300 kilometers. It would be pretty common to hear someone answering metric for driving distance. But they even have like a grandpa or a dad or an uncle or something who's a farmer. If you ask your farmer grandpa how far something is, he's certainly going to tell you miles. But there's actually a good reason. It's not just because he's old. It's because our whole province, actually our whole country, is surveyed in miles. Right, so when you're driving along, you see those range roads and township roads, and those are telling you every mile. Right, so it's like range road 20-2, range road 20-3, 20-4, 20-5, and then 21-0, 21-2. Right, it's going up by 1 mile increments. So it makes the most sense to say, oh, that road was 6 miles that way. So there's 6 range roads since you passed it. Right, each one of those was surveyed at a mile, and they probably actually know their land. Hey, my land. I own, 2 sections and a quarter section or whatever, which is chunks that are 1 mile by 1 mile, 1 mile by 1 mile, and then the quarter section is a half mile by half mile. Yeah, so.
Like in sports, you can say it goes on in miles, not like it goes on.
Interesting. So that slang is still using the imperial thing. So Canada changed from imperial to metric when like my dad was in school. It was like 1970 something, right? It's not super long, but still within the living memory of lots of people. And it's kind of partially up. Now, of course, a large part of why that is also our neighbor to the south, our closest neighbor, still uses the imperial system. So a lot of those things, when your closest trade partner uses imperial, we still end up using imperial in lots of ways. They're 10 times the size of us, so lots of what we get comes from them. But if you're looking at the green road signs and stuff, that's all kilometers. If you're talking about distances in the school or something like that, it's probably mostly going to be meters. What I'm trying to point out is it's sort of a mix of what gets used. So in this class, we want you to be able to use both metric and imperial measures of distance and other things. Here's some conversions. This doesn't show anything with conversions in metric, but metric is really easy to convert, isn't it? Like, how would I convert something from meters to kilometers? Yeah.
When you use acres or your
Acres? Oh, that's great. So this is a great question. It's units of area. So, like, if we were talking, I mentioned earlier that like most of our province was surveyed in increments that are 1 mile by 1 mile, and then, hey, well, if you ask this question, I'm going to answer it for you. So it was surveyed in these mile by mile segments, and then usually you'll actually talk about those mile by mile segments broken into quarter sections. So here's a perfect map of Alberta. Wow, isn't that amazing? Here's us. But in the very southeast corner of the province is what we would call Township 1. And it will slowly work up in mile by mile. Actually, each township is 6 miles by 6 miles, and then broken up into 1 mile by 1 mile chunks. But so in this township, you have your perfect 6 blocks. And as you can tell, I measured this exactly, so every square is exactly the same. Exactly 1 mile by 1 mile, right, Malak?
Yeah.
Okay. And you're asking what acres. So what an acre is, it's a unit of area.
Yeah.
Unit of area. So we don't say that's in general like mile by mile squares. Instead, they use the units of acres. And in metric, they use hectares, which is kind of weird because, like, for distance, we don't really use hectameters. We mostly use kilometers or meters. But for some reason, the surveying unit for area is hectares, usually, which is like hectometer squared. But acres are just a unit, which is measuring area. And each of these sections, one section which is 1 mile by 1 mile, I think is approximately equal to 620 acres. So that's how they're used. It's like 165 per quarter section. So it must be 630 then? Yeah. 660, whatever the number is. 600 and something acres in a section. So it's just a measure of area. Okay, anyways. So first of all, talking about distance. These are some of these conversions. The only other one that's really significant and stuff within metric is always a factor of 10. So it may be worth writing on your page and just remembering you would have seen this lots in 10-3 and or 20-3. Kilometer, hectometer, decameter, meter, decimeter. Isn't that annoying? 2 of them that start with a D. You'll either see decameter as capital DM or DAM. Those are both talking about the same unit. Although you'll never see it used, so it won't matter. And then centimeter and millimeter. Probably the only ones you'll actually run into are kilometer, meter, centimeter, and millimeter. And the way we convert within metric is times 10, times 10, times 10, K then H, kilometer then hectometer. And if we're going the other way, we're instead dividing by 10, right? Or put more simply, the reason why I listed them in this order is like if I'm going kilometer to meter, it's basically move the decimal 1, 2, 3 spots. Or move the decimal centimeter to meter 1, 2 spots that way, right? So if it's something metric to metric, you're just going times or divided by however many tens. So in this case, it would be like, if we're saying, let's say 7.8 kilometers into meters, that would just be move the decimal 1, 2, 3 spots over. So we'd have 7,800 meters, right? That's how metric works, is times tens and divided by tens. But when we're working from imperial to imperial or metric to imperial, we have slightly less clean conversion rates. This is where we're using these different conversion rates. So to convert some, if we're going feet into yards, for example, well, it looks like it's 1 yard into 3 feet. Because you guys are 30-3, I'm going to not try to insult your intelligence. I'm guessing that you've probably done this in several different ways. Yes? Looking at this, who's like, okay, I can just do this by multiplying by 12 feet and how many yards? What do you do? Yeah, so how are you doing? Sorry. I don't mean like, how are you doing? Solve it. How are you going to solve it?
For 12 feet? Yeah. Okay. So you go to where the feet is, and then you do it 5
What
yards.
feet? What feet?
Okay, Cole, what'd you do?
Divide by 3.
Okay, great. And how did you know to divide instead of multiply?
Because it goes up.
Okay. Hey, wait. This is good insight.
Feet by yard.
Okay. So Cole is suggesting. He recognizes that there are more feet, like there's multiple feet in a yard. The feet are the smaller units. So to go from feet to yards, he knows you need to divide. The number needs to get smaller. Sure. Absolutely. For lots of you, you're going to be fine to know it multiplies or divides because I'm going from a bigger number to a smaller number or a smaller number to a bigger number. That's often enough. That's great. That's what I will do in real life. If I'm going feet to yards, I know it's a conversion rate of 3. Feet to yards, well, yards are bigger, so I need to take the feet that I have and divide it to get to the yards. Great. However, I often talk about the similarities with science. I really love unit conversions in science. I like dimensional analysis, that kind of stuff. What you would have done in 10-3 and 20-3 is more likely setting up a proportion. And proportions are great. This is a good situation to do a proportion if you want. Your proportion would have looked like 1 yard is 3 feet, which is equal to 12 feet is x, and you end up doing exactly what Cole said. 12 times 1 divided by 3, 12 divided by 3, you end up with 4. This is what you would have done in 10-3. I'm perfectly happy with you doing it. I'm not going to do this at all in 30-3. I'll very, very rarely use a proportion. Not because it's wrong. In fact, the math is going to be exactly the same as what I'll do, but I'll show you how I'd set this up instead. What I'm going to do is called unit analysis or dimensional analysis. If you take in Science 20, actually even Science 10 or Chem 20, and any of those, you'll have done this a lot. All that you do for unit analysis is, first of all, you write down what you have. You write down what you start with. So I write down 12 feet. And then I start multiplying it by conversion rates. So 12 feet, and I'm going to multiply that by, my goal here is cancel out units and get to whatever units I want. I want yards. I see that my conversion rate here is that 1 yard equals 3 feet. By the way I've set this up and going by multiplication, foot divided by foot cancels. So I'm just left with 12 divided by 3. Anyways, that's a whole lot of explaining to recognize that 12 divided by 3 is 4. Right? The nice thing about this, though, is I really like this in a situation where I'm asked to go, let's say, from like inches to kilometers or something, where there's 2 conversions I need. Let's say that I was asked to go from, yes, Milan?
So I was right?
You didn't even answer that.
Yes, because like you just did what equals 12, so you did 3, 6, 9, 12, 4, right?
Yes, we've established the answer is 4. Great. Yeah.
Yeah, so I was right.
No one heard you say 4.
Yeah, I didn't say
This
4.
isn't your show.
I said feet by yard.
Okay, sure. So if we're trying to go from centimeters to miles, let's say I was told that I need to have, or maybe meters to miles, to make more sense. Let's say I know that I have 10,000 meters, and I want to know how many miles that is. In a situation like this, there's no like direct connection. But you're asked how many miles is 10,000 meters or something like that. Well, the reason why unit analysis is really nice is I can just take this number and do multiple conversions all at once. So in a situation like this, okay, I don't know how to get to miles from meters, but I see that I can get to miles from yards. Okay, I can get to miles from yards. And if I went back here, you guys don't have this in front of you, so there's no way you would have known this. But going from imperial to metric, 1 meter, let's see what our conversion rate is here. 1 meter, or 1 yard equals 0.9144 meters. So I go, okay, 0.9144 meters equals 1 yard. Yep. Okay, so I haven't yet got to yards, but if I wanted to get to miles, I can just keep going with this. I can say, okay, I've got this set up partway. And don't worry, you're not actually asked this. I'm just trying to show you why I like unit analysis. So now I have yards. I'm trying to get yards to miles. Well, now I have this conversion rate. 1 mile equals 1760 yards. So it's like, okay, now I know I want miles. 1 mile equals 1,760 yards. Okay, my yards cancel. And you see how I basically just set up one calculation to find meters all the way to miles? That's kind of the benefit of unit analysis, like a one big calculation where I can get from some unit to another. I actually wouldn't make you do this, going 2 steps through here, but this is a really normal kind of question when you're having to convert in any sort of science question, or in actually lots of just like distance questions. So in this case, okay, it's 10,000 divided by, and I'd bracket 0.9144 times 1760. and I realize, oh, how many miles is it? Well, 10,000 meters, which by the way is just 10 kilometers, ends up being 6.2 miles. So that's the benefit of unit analysis. Okay, that's why I like that. It lets me do these two steps in one big calculation. Cool. Okay, blah, blah, back to easy ones. 72 inches is how many yards? Well, I see that 1 yard is 36 inches. So using the patented Cole method, I know that inches are smaller than yards, so I need more of them. So the thing that gets me more of them is dividing. There's more inches, so I need less yards. The thing that gets me less of them is dividing. 72 over 36 is 2 inches. Simple enough. And like that's what you were trying to get at, right? Is you're just dividing the one by the other. Cool. Or inches into feet. Inches into feet. Okay. Well, how many inches are in a foot? 12. Okay, so there's a bit of a trick here. If you just take 17 inches, divide it by 12, you're going to get 1 point something, right? And that's perfectly fine. What is the number? 1 point?
1.416.
Okay, so sure. 1.416.
And then it goes 6 and 6 and then right at
Yeah, it's 6 you're beating. I got you. It would be 6 you're beating with 7 just rounding on your calculator. But let's think about this. If you see a height list, Carter, how tall are you again? Why didn't you say 5.75? Why did you say 5 foot and 9 inches? Well, he actually, that's sort of what he did. He wasn't actually rounded. He chose to use the bigger units and the smaller units. He didn't just answer me. He answered the feet and inches. Okay, that's all. Is that 6.5 feet or 6 feet and 5 inches?
65 inches.
Is there a difference, by the way? What would 6.5 feet be?
66?
Yeah, right, because each half foot is 6 inches. Great insight. So Caden is not 6.5 feet. He's 6 feet and 5 inches, which is 6.416 feet, or something like that if we were doing it as a decimal. Now, in general, if you're asking Imperial, the assumption is actually you should answer feet and inches. You shouldn't just answer feet. I recognize this says equals blank feet, and 1.416 feet is factually true. It's fine. But I think it's more useful to say 17 inches is equal to 1 foot and 5 inches. Right? It's like, what's the remainder? So 1 full foot plus 5 inches is what's left over. This is almost like when you were in grade 4 and you learned how to long divide, you cried for 12 hours. Because long division is when everyone realizes that, math will beat you.
It was literally the worst thing to ever experience.
Yeah, long division is pretty hard division, I get that. But you're all confident long dividers now. Anyways, this is kind of like that. It's like, remember how, 63 divided by 5, you're like, oh, well, that's 12 and something. It's 12 and 3 left over. That's like this, right? It's 1 foot, which is 12 inches, and there's 5 inches left. So the way I would actually answer this is like, how is 17 inches? Well, 17 inches into feet, well, that's 12 inches plus 5 inches, right? How many full feet plus what's left over? Okay, so I think 1 foot 5 inches is a better answer than 1.416 feet, though they're both technically true. Okay, that only really applies though to small units like that. Being frank, you're not going to turn feet or miles into like feet and inches or something like that. So it's sort of like in units that we use like that. That's kind of what we do. Other ones, I guess, we won't. Okay, 2 miles into feet. What's the conversion rate? Miles into feet. Okay, so let's think. If we're using the patented Cole method, are we multiplying or dividing?
Multiply.
Yeah. If you go 2 divided by 5,280, you're going to get a really small amount of feet, but there's definitely going to be more feet than miles, right? I'm really hammering this home. I'm sorry, it's probably seeming redundant. You're like, yes, we get it. The reason why, though, is because when we're going from, in this case, a really big unit to a really small unit, sometimes we think, oh, then I need to get the unit smaller. No, but when you're going from a bigger unit to a smaller unit, you need more of the smaller unit, right? It's like, I need way, way, way more feet to make up a mile. So the unit's smaller, I need more of them to make up the same shape, the same space. Yes, we get it. Move on. Okay, sorry. So that ends up being then 2 times 5280. I'll show it with my unit analysis. So 2 miles times conversion rate, 1 mile per 5280 feet. Miles canceled. And then left with what's that? 10,560 feet. Alright. That match what you got, Hassan? Huh? Does that match what you got on your calculator? Calculator that you're using while you're working along?
I think he's talking about your telephone.
I actually wasn't. I was just pointing out that you didn't have a calculator. It's hard to follow along without a calculator. That's all. Okay. How about this? How about this? Now, this is actually where we're going to kind of get started thinking about the limits of our measurements and what works and what doesn't. Oh, I also see I'm going to get cut off very rudely very soon, so I better stop here. How do you measure something smaller than an inch? Well, you break it into pieces. Just like we're talking about feet and inches. Similarly with feet, we don't say it's 5 or 5.2 inches. We say it's 5 feet and however many fraction of an inch. Generally within inches, what most tape measures will break something down into is 1/16 of an inch. That'll be the most common, though sometimes you'll see 30 seconds or even 64ths of an inch. But like if you look at this tape measure, if I break this into inches, it doesn't have like tenths, it's broken into fractions. And this one you can see how it's like half, quarter, 1/8, 1/16, and even all the way to 30 seconds. Actually, you can't see that. I'm just hoping that you'll take it my face. But if Silver can see it from here, she'd have superhuman eyes. In this case, the way we would break up these inches, kind of 2 ways of doing this. Lots of students will just count them. They'll say, okay, there's 1, 2, 3, 4, 5, 6, 7, 8 ticks in between. I'll label each of them as 8s. The other thing people will do is they'll look at the inch. They'll go, okay, half, quarter, 1/8. Either of those are fine. The thing, though, that is worth recognizing is you do always want to reduce fractions. So, like, I'll sometimes see people label it like, okay, this is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then 1. Is that how I actually want to label this? Malak, you can't leave right now. Sorry, you're not in trouble. You just can't leave. So I don't want them labeled like this. What's the thing I should have done here? What's a better way to call 2/8?
1/4.
What's a better way to call 4/8?
1/4.
What's a better way to say 6/8?
3/4.
Yeah. So we should simplify fractions, right? Which is kind of funny. So if you're like counting on a tape measure, which I was playing a poker game last Friday, talking to someone about high school math and all the things they didn't need. He literally said the only thing they use. This is not a guy who's super highly educated. He's also a guy who is like low man on the totem pole in a construction crew. But he said the only thing I do is count by inches. The only thing I do is count fractions. So this one guy was saying this is the only thing I do. Now, for lots of you, you'll do more than just this, but he was saying this counting by fractions is actually the skill he uses. So anyway, so the way we'd be counting here is 1/8, 1/4, 3/8, 1/2, 5/8, 3/4, 7/8, 1. Right, just being able to recognize what these are. Don't worry, Rita, I'll do it up here a little more clearly. 1/8, 1/4. 3/8, 1/2, 5/8, 3/4, 7/8. Okay? That's what we're dealing with there. Where's Joanna?
We don't know. Joanna was gone for like 3 hours.
Well, not 3 hours. He's been gone for a while.
Yeah. Can I go look for him?
No. Good try, though. This shows you how far we'll go for your safety.
You really cared so far about the student.
Okay, so then using sort of this kind of measurement, I found when we did this in 10-3, lots of students struggle with this. It's kind of hard. So looking at a screw like this, how big is this screw? Well, what you start with it's 2 inches. It's 2 inches and, okay, 2 inches and Then what fraction from 2? Yeah, 2 and 3/8. That's 2 and 3/8 of it. How about this t? This is 3.
3 and 2 and
3 and 2 what's?
2 bucks.
No, what are the fractions? 3 and 2 what's?
8.
Okay, and how do you simplify that? That's just the sign for inches.
1/4.
Yeah, nice. So this is 3 and 1/4.
20.
Cool. 3 and 1/4, 2 and 3/8. Okay, you guys can start practicing.
11.
That's not 11, it's inches. That's the sign for inches. It's like 2 dashes.
Oh.
You'll see, no, sorry, you can't go. It's not because of anything you've done, it's because it's going to be something that makes us not able to go. Okay, this is the sign for feet, this is the sign for inches. So like, my height, that's that, right? That's how that would be labeled.
Okay. Can you go up a little bit?
I should-